So, I was solving this very difficult math problem the other day, and it took me 90 minutes before I was finally able to get it. But the result was very satisfying when I did. And here, what the question was this: find all natural numbers for a, b, and c such that 1 plus 1 over a times 1 plus 1 over b times 1 plus 1 over c is equal to 2. So natural numbers are basically positive integers you can count with your fingers: 1, 2, 3, 4, 5, etc., etc. So how do we do this? Well, the first thing you should do is you should be able to recognize that this is actually a very good question. And what I'm going to do is I'm going to say, so I'm going to write the question out first: 1 plus 1 over a, 1 plus 1 over b, 1 plus 1 over c is equal to 2. So this is the same thing as saying x, y, z is equal to 2 for x is equal to 1 plus 1 over a, y equals 1 plus 1 over b, and z is equal to 1 plus 1 over c. And yeah, so basically this is going to help us in the long run. So first of all, I want you to notice two things. The number one, this equation is symmetric. This means that it doesn't matter if I swap the values of A, B, and C, you're still going to get the same value. So if, for example, if one solution was A equals 1, B equals 2, and C equals 3, like f of 1, 2, and 3, that's the same as f of 2, 3, and 1, and that's the same as f of 3, 2, and 1. You get the idea. It doesn't matter if you have a certain set of values for A, B, and C if you swap the order around. So for that reason, WLOG, let A be our test variable. And you'll very quickly see what this means later on. It doesn't matter what our test variable is. You can choose B to be your test variable, or even C. I'm just going to use A. So that's the first thing to note. The second thing is that A, B, and C cannot equal 1. Cannot equal 1. And here's why. If it did, let me give you an example of what would happen if it did. If A equals 1, if A were to equal to 1, you would have X is equal to 2. So then you'd have X, Y, Z is equal to 2, which means that Y, Z would just equal to 1. And the maximum you could do, at most, it would be Y equals 1 and Z equals 1. Y and Z equal 1. And for something like Y, you'd have like 1 plus 1 over B equals 1. And then 1 over B would be 0. And so would 1 over Z, and then 1 over C, and then B would equal infinity, but infinity is not a natural number, so this would not work. So as a result, A, B, and C have to have a minimum value of 2. So the best way to solve this problem is really to just guess and test. You use A as your test variable, you start at the lowest possible value, and then you work your way up until you run out of answers. So suppose A equals 2. Remember, A is our test variable. You could say B equals 2 or C equals 2. I'm just saying A equals 2. So if A were to equal 2, X would equal 1 plus 1 over 2, which is 3 over 2. And X, Y, Z is equal to 2. So 3 over 2 Y, Z is equal to 2. And then you'd have YZ is equal to 4 over 3. Now, once again, WLOG, without loss of generality, once again, suppose y is less than or equal to z. The order really doesn't matter. You could say z is less than or equal to y. You'll get the same result. But I'm saying suppose y is less than or equal to z. And in this case, you would have the maximum value of y is z. So then you'd have y squared is equal to 4 over 3. And then you have y is usually you do plus or minus 2 over 3, but here then y is equal to 2 over 3. This is the max value of y. This is roughly equal to 1.15 if you put this in your calculator. So what is the minimum value of b that it's equal in order to achieve the maximum value of y? So if b is equal to 2, then you get y is equal to 1 plus 1 over 2, which is 1.5, clearly greater than 1.15. If b equals 3, y equals 1 plus 1 over 3. That's roughly equal to 1.33. That's still bigger than 1.15. If b is equal to 4, y is equal to 1 plus 1 over 4, which is equal to 1.25. That's clearly bigger than 1.15. So no, if b is equal to 5, then y is equal to 1 plus 1 over 5, which is equal to 1.2, which doesn't work. If b is equal to 6, y is equal to 1 plus 1 over 6, which is roughly 1.16, but that's slightly bigger than 1.15. But if b equals 7, then y equals 1 plus 1 over 7, which is roughly 1.14, which is within our maximum limit. So yes, the b equals 7 works. So therefore, if a equals 2, b has to be at least 7. So suppose a equals 2 and b equals 7. Let's find what c would equal. So then you'd have 1 plus 1 over 2 times 1 plus 1 over 7 times 1 plus 1 over c would equal 2. Then that's 3 over 2 times 8 over 7. 1 plus 1 over c equals 2. This is 4, and that would just be 1, so that's 12 over 7. 1 plus 1 over c is equal to 2, times both sides by 7 over 12. And you'd have 1 plus 1 over c equals 7 over 6, and then c is equal to 6. So if a equals, possible solution set, one possible solution set is 2, 6, and 7 in any order because this equation is symmetric. Okay, so that means that the 6 possible solution sets are a equals 2, b equals 6, c equals 7, a equals 2, b equals 7, and c equals 6. If b were to equal 2, then a equals 6 and c equals 7. And then b equals 2, and then a equals 7, and c equals 6. And lastly, if C were to equal 2, A equals 6, and B equals 7, and the final solution would be A equals 7 and B would be equal to 6. So these would be the 6 possible solution sets if you were to get 2, 6, and 7. So that is one. But another thing, so the maximum value of C would be 6. So if A is 2 and B is 7, then the maximum value of C is 6. So, meaning C is equal to 2, 3, 4, 5, and 6. So we found one solution set, and let's just keep going down the line with 2, 3, and 4, and 5. We've already seen what happens if A equals 2 and B and C equals 6. So if A equals 2 and C equals 5, 2, and C equals 5, let's see what happens. Then you'd have 1 plus 1 over 2, 1 plus 1 over 5, and then times 1 plus 1 over B is equal to 2. So then this is 3 over 2 times 6 over 5. 1 plus 1 over B equals 2. Then this is 3 and 1. 9 over 5. 1 plus 1 over B is equal to 2. 2 times 5 over 9. So then 1 plus 1 over B would equal 10 over 9. And then B would equal 9. So another possible solution set would be 2, 5, and 9 in any order. So that would mean that A equals 2, B equals 5, C equals 9, A equals 2, B equals 9, C equals 5. If B were to equal 2, then A equals 5 and C equals 9. B equals 2, A equals 9, C equals 5. And if C were to equal 2, A equals 5 and B equals 9. And the final is A equals 9, B equals 5, and C equals 2. Let's keep going down the line. Now suppose if C were to equal 4. Okay, so then you'd have 1 plus 1 over 2 times 1 plus 1 over 4 times 1 plus 1 over B is equal to 2. 3 over 2 times 5 over 4, 1 plus 1 over B equals 2. 15 over 8, 1 plus 1 over B equals 2. So then 1 plus 1 over B is equal to 16 over 15. And that would mean B equals 15. So the third possible solution set is 2, 4, and 15 in any order. So that means A is equal to 2, B equals 4, C equals 15, A equals 2, B equals 15, and C equals 4. third one is if b equals 2, a equals 4, and c equals 15. If b equals 2, a equals 15, and c equals 4. And the last one is the last two, c equals 4, a equals 4, b equals 15, and a equals 15, b equals 4, and c equals 2. I'm still getting used to this pen, guys. Moving down, if a equals 2 and c were to equal 3, so let's just plug that in. 1 plus 1 over 2, 1 plus 1 over 3, 1 plus 1 over b is equal to 2. Then you'd have 3 over 2 times 4 over 3. 1 plus 1 over b equals 2. So then this is just 2, and that would be 1, and 3 cancel out. So 1 plus 1 over b would equal 1, and 1 over b would be 0, but this doesn't work because then b would be infinity. So if a was 2 and c is 3, there's no solutions. There's no viable solutions here. So, and the last one is if a and c were both equal to 2. So 1 plus 1 over 2, 1 plus 1 over 2 times 1 plus 1 over b equals 2. 3 over 2 times 3 over 2, so that's 9 over 4. 1 plus 1 over b is equal to 2. 1 plus 1 over b would equal 8 over 9. But then you'd have 1 over b is equal to negative 1 over 9. No, b can't be negative. So you'd have no solution sets here either. So that means we've found all possible solution sets for the value 2. So we can move on to 3. Okay, now let's move on with our test variable. Suppose a was equal to 3 now. What would we do? So then x would equal 1 plus 1 over 3, which is equal to 4 over 3. So then x, y, z is equal to 2. So then 4 over 3 y, z is equal to 2. And y, z would equal 3 over 4. No, sorry, 3 over 2, which is equal to 1.5. Using the same tactic once again, suppose without loss of generality, y is less than or equal to z once again. Okay, so then y squared equals 1.5, and that means y would equal the square root of 1.5. And when you put that in your calculator, you get an approximate value of 1.22. So this is the maximum value y can possibly be if a was to equal to 3. Okay, so let's just test our b values and see when it is acceptable. So if b was equal to 2, y would equal 1 plus 1 over 2, which is equal to 1.5. That's too high. If b was equal to 3, y would be equal to 1 plus 1 over 3. That's roughly 1.33, like repeating and all that. So that's also too high. If b was equal to 4, y would equal 1 plus 1 over 4. That's 1.25. Still too high. But if b was to equal 5, y would equal 1 plus 1 over 5, which is equal to 1.2. That's less than 1.22, so we've got it. So therefore, if a equals 3, then b has to be at least 5. So let's start off with b equals 5. So let's suppose a equals 3 and b equals 5. Plugging that into our original equation, so that's 1 plus 1 over 3, 1 plus 1 over 5, times 1 plus 1 over c is equal to 2. So 4 over 3 times 6 over 5. 1 plus 1 over c is equal to 2. 6 and 3, you get 2 and 1. So 8 over 5. 1 plus 1 over c is equal to 2. Then so the 2 times 5 over... Okay, so 1 plus 1 over c is equal to 5 over 4, which implies that c equals 4. So, b has to be at least 5, which means the maximum value of c is 4 here. So, c equals... The possible values are 2, 3, and 4. And a possible solution set is 3, 4, and 5 in any order. So, listing them all out again, a equals 3, b equals 4, c equals 5, a equals 3, b equals 5, c equals 4. If b was to equal 3, then a can equal 4, and c can equal 5. If, also... 4, and c equals a equals 4, b equals 5, and the last solution is a equals 5 equals 4, and c equals 3. These are the 6 solutions. Okay, now so we've tested if c was to equal 4. Now let's see if a and c were both equal to 3, what would happen. So then you'd have 1 plus 1 over 3, 1 plus 1 over 3, 1 plus 1 over b equals 2. Okay, putting that in. So 4 over 3 times 4 over 3, that's 16 over 9. 1 plus 1 over b equals 2. Okay, so then times 9 over 16. Okay, 1 plus 1 over b would equal 9 over 8, and b would equal 8. So another possible solution set is 3, 3, and 8 in any order. So there's only 3 solutions. A equals 3, B equals 3, C equals 8, A equals 3, B equals 8, and C equals 3. And lastly, A equals 8, B equals 3, and C equals 3. These 3 solutions. Lastly, if A equals 3 and C equals 2, well, I'm not sure if you guys remember, but previously, when I said A equals 2 and C equals 3, we actually didn't find any solutions. There are no solutions, as shown earlier. When A equals 2 and C was to equal 3. So these are the only 9 solutions when A is equal to 3. Let's move on to the value 4 now. Okay, so now let's suppose our test variable A was equal to 4. What would happen now? So once again, you'd have your x equals 1 plus 1 over 4, which would be 5 over 4. And xyz is equal to 2, so 5 over 4 yz is equal to 2. And then you'd have yz is equal to 1.6. Using WLLG again, suppose y is less than or equal to z. Okay, so then you'd have y squared equals 1.6. We've done this 3 times, so I'm just like speeding up this process here. So y would equal the square root of 1.6, and when you plug that into your calculator, it's roughly 1.26. This is the max value y can be. Now, I already know this by inspection, and I've already done this before. You test out b equals 2 and b equals 3 and 4 and see which value would be underneath or equal to 1.26. B would have to be at least 4 here. Okay, so let's suppose, yes, let's try. Suppose A equals 4 and B was equal to 4. What's the maximum value C can be? Okay, so then 1 plus 1 over 4 times 1 plus 1 over 4 times 1 plus 1 over C is equal to 2. So 5 over 4 squared is 25 over 16. 1 plus 1 over C is equal to 2. Times both sides by 16 over 25. So 1 plus 1 over C is equal to 32 over 25. And 1 over C equals 27 over 25. And C would equal 25 over 7. Which is roughly, it's slightly higher than 3.5. So that means C as maximum 3.5. So the possible values of C are 2 and 3. Okay, well, let's just test it out. If A equals 4 and C equals 3, then we get B equals 5, which leads to the solution set 3, 4, and 5, which was already found. And if A was equal to 4 and C was equal to 2, then B would be equal to 15, and you get the solution set 2, 4, and 15, which it was already found previously when we assumed A was equal to 2. So there are no no new solution sets. No new solutions. Now, you might be wondering, so are we just going to keep going on to infinity for A? Well, no, because you see, we're actually about to end this question now. I'm going to erase this entire thing first, and then I'm going to show you why we're basically done. So, this is an observation. As our test variable A increases, as A increases, the value x decreases. X decreases, because x equals 1 plus 1 over A. As A keeps going up, x will keep going down. Yeah. And so, as x decreases, and as x decreases, y and z both increase. Both increase. I apologize for my handwriting. Please forgive me, guys. Both increase. Now, here's the thing. As z increases, the value of c decreases. Do you guys see why? Because z is equal to 1 plus 1 over c, and yeah, c has to decrease in order for z to increase. Yeah, okay. So this means, like we've been using this same strategy on and on. So this means for a greater than or equal to 5, the maximum value of c is c equals 2 and 3. When we found this back when a was equal to 4. However, we already found all values for 2 and 3. Therefore, we have found all solutions to the question. Therefore, we have found all the 27 solutions to this question, and we are now done this question.